Hi everyone, so in this video I'm going to be going over chapter 10.4, which is the Algebra of Matrices. So we can tell that matrices are equal. So in this way, we have matrices A equals Aij and B equals Bij, where I and J are the subscripts. And they're equal if and only if they have the same dimension n by n and corresponding entries are equal. So I have Aij equals Bij for I equals 1, 2, all the way to m, and B equals 1, 2, all the way to n. So for example, I have the matrix A, B, C, D. This equals 1, 3, 5, 2. So these matrices are equal when A equals 1, B equals 3, C equals 5, and D equals 2. So they have the same dimension. They're both 2 by 2, and they have their corresponding entries are equal. So we can also add, subtract, and multiply by a scalar in matrices. So let's go over our sum and differences. So let's have our matrix A equals Aij and B equals Bij. So they're matrices of the same dimension, n by n, and then we're just having C be any real number. So the sum of A plus B is the m by n matrix, so the dimension stays the same, obtained by adding corresponding entries of A and B. So I could add A and B by adding corresponding entries, and I get my resultant matrix. So the difference A and B is the m by n matrix, so the same dimension, obtained by subtracting corresponding entries of A and B. And then the scalar product CA is the n by n matrix, obtained by multiplying each entry of A by C. So let's go ahead and do an example. So I have A equals 2, negative 3, 0, 5, 7, negative 1 half. B is 1, 0, negative 3, 1, and 2, 2. C is 7, negative 3, 0, and 0, 1, 5. And D is 6, 0, negative 6, 8, 1, 9. So for A, I'm going to add A plus B. So I have the matrix of A plus the matrix of B. So I add corresponding entries. So I'm going to add 2 and 1, and then I get 3. So it's in the same position that it was in the matrix, is where the 2 plus 3 is, or 2 plus 1 to get 3 is. And then I have negative 3 plus 0 here. And then my negative 3 is 0 plus negative 3. 5 plus 1 is 6. 7 plus 2 is 9. And negative 1 half plus 2 is 3 halves. Okay, now I have C minus D. So I have a 2 by 3 matrix minus a 2 by 3 matrix. And I'm going to subtract corresponding entries. So I have 7 minus 6 is 1. Negative 3 minus 0 is negative 3. 0 minus negative 6 is 6. 0 minus 8 is negative 8. 1 minus 1, 0. And 5 minus 9 is negative 4. So C plus A. This is undefined because we can't add matrices of different dimensions. So A is a 3 by 2 matrix and C is a 2 by 3. So these are different dimensions. So dimension of C equals 2 by 3, and then dimension of A equals 3 by 2, and these are not equal to each other. All right, now I have 5A. So I'm going to multiply each, so 5 is a scalar, and I'm going to multiply each entry in A by 5. So 5 times 2 is 10, 5 times negative 3 is negative 15, 5 times 0 is 0, 5 times 5 is 25, 5 times 7 is 35, and 5 times negative 1 half is negative 5 halves. Alright, and then here are some properties of addition and scalar multiplication in matrices. So it's the same as real numbers, where we have commutative property, associative matrix addition, associated with scalar multiplication, and distributive properties. So I have A plus B would equal B plus A plus B plus C equals A plus B plus C, just with the different parentheses. C times dA equals C times dA, so it's associative in multiplication. And then my distributive properties stay the same with scalar multiplication. So for this example, I have 2x minus a equals b, and I want to solve that when a equals 2, 3, negative 5, 1, and b is 4, negative 1, 1, 3. So I have 2x equals a plus b, and I'm going to go ahead and divide by 2, and I get x equals 1/2 a plus b. So now I'll go ahead and plug in my matrices. So I have 1/2 times the a plus b added, so I'm going to go ahead and add the matrices first. So I have 6, 2, negative 4, 4, and then now I could scalar multiply this by 1/2, and I get 3, 1, negative 2, 2. Okay, and then you're probably wondering, okay, we're multiplying by a scalar, but what happens if we multiply by a matrix? So this chapter covers matrix multiplication, but I'm not going to go over that here. But if you definitely want to look into that, I'm not requiring you guys to know how to matrix multiply, but if you're interested, you can find it in the chapter. But something good to know is that matrix multiplication is not commutative. So if we had matrix AB, it may or may not equal BA, but most likely it doesn't. So AB does not equal BA when we're multiplying by matrices. If we're multiplying by a scalar, they are commutative, but matrix multiplication is not commutative. Okay, I'll see you in the next video. We'll be going over chapter 10.8. So I will see you there.